Janelle's like, wait, I might have got one. Okay, here we go. You guys ready? I want this a little bit smaller, so I'm put in my blanks. What should you be using right now in order to, correct and whatnot? Why? So you can look back at your bell work and be like, hey, this is a multiple choice. The test has multiple choice. What did I get wrong in class? Oh, I know how to do that now. Oh, I don't know how to do that now. Maybe I should study that for the test. You guys follow my logic there? Okay, here we go. Number 89. You were supposed to find what? Oh, kind of, okay. Sometimes I assign these for homework, so sometimes we're seeing them for a second time, but sometimes I don't assign them so we can do this in class together. Anyway, here we go. To find this, I think I need, let's see, f inverse prime of b equals 1 over f prime of a, right? Okay, so 40 goes here, but 40 does not go here, because what are we supposed to be, where are we supposed to be getting that from? Because 40 is the x of the inverse, which means it's the y of the original. Oh my goodness, what are we supposed to do? Subtract the 40 and factor. Square both sides, which actually would work. If you were to square this side, you would get something big. What is that, 1600? If you square this side, the square root would go away, and then you'd end up having a polynomial. But remember what I told you? If the computational stuff gets hard and complicated, what should you try to do? Oh, come on, it's in the forever card with a star. By the way, we have to have a forever quiz soon, yeah? If section 2.7 is our last section. Yeah, plug in stuff. Plug in what? Sure. Does 1 work? No. How about 2? No. How about 3? Wait a minute. This can't even start until what? Till 6. So keep going. How about 7? 14 and 1. No. How about 8? Square root of 2. That's not going to work. Okay, what's the next perfect square? 10? Now wait a minute. 10's a long way from 1 or from 0. But what did I use in order to be plugging and chugging? Domain. Can't even start until 6, and that's 0. Gotta get bigger. 7, square root of 1, not big enough. Square root of 2 is gross. Square root of 4 was the next one. Oh, that's 10. 20 times the square root of 4. 20 times 2 is x equals 10. As soon as we have 10, we're good to go. Well, kind of. What do we need for this? F prime. Oh, a bummer. Okay, so coming over and doing f prime, we have a little baby product rule, right? Second, d first plus first. 1 over 2 square root is 1. Why did I do times 1? U prime. Because I had u to the 1/2, so I brought down the 1/2, negative 1/2 times u prime. And what's the point? What am I supposed to be plugging in? 10. Could we make it pretty? Sure. Could we not make it pretty? Sure. So I'm going to go ahead and have the square root of 10 minus 6 is 4 times 2 plus 2 times 10 times 1 over 2 square root of 10 minus 6 is 4. I have, what do I got? That's going to be 2, right? 2 times 2 is 4. That's going to be 20. That's going to be 2. 2 times 2 is 4. So I end up with 1 over 4 plus 20 over 4, which would be 1 over 9. Dun, 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 dun. Anybody double check my mental math? Sorry. 2 times 2 is 4, 20. 2 times 2 is 4, 20 over 4 is 5, 5 and 4 is 9. Yeah. Pause. Why was this a hard AP type question? What was difficult about it? How many things were necessary? What's this step? Using the formula. What's this step? Finding the A from the B, but yeah, the X to plug in, right? What was the next step? Needing to take the derivative, and then the last step was just needing to simplify a lot of numbers. So we had to go from formula to finding X to actually finding a derivative to plugging in and simplifying and getting it correct. Were there a lot of places you could make a mistake or get stuck? Yes, but was it possible? Using our forever card. Number 90. Pause. Did anybody get that one right? Number 89? Nice. We got 2. We got 2. How many of you guys got at least the idea, even if you got stuck? Sorry, I need some more space over here on this page. Number 90. What are you supposed to do, guys? Yeah, formula 4. Wait, arctan, who's that guy again? Tangent inverse. So hopefully some of you guys are starting to memorize that formula. In third, it's just a constant. But when I go to plug into my formula, isn't it 1 over 1 plus u squared times what? Ooh, who's my u? Now I'm going to go ahead and really write just 1/3, really quickly write 1/3. But some of you are like, how'd you do that so fast? How did some of you take his derivative? If you did, hopefully do a u prime. Quotient rule. Is that illegal? No. It is a quotient. But what happens when you do quotient rule? You'll have bottom d top, which will be 3 times 1, minus top d bottom, which is 0, all over bottom squared, which is 9. You get 3 over 9, which is 1/3. What's another way of getting that? You could have rewritten. I'm not judging your quotient rule. I just know the AP is timed, and so I'm trying to show you tricks to speed you up. Does that make sense? What's the derivative of 1/3 x? 1/3. Also, quotient rule works, but so does rewriting and then deriving. We need to simplify. Oh yeah, obviously. No. Well, 1/3 and 1/3 makes 1/9, right? And then I have 1/9 times 1 over 1 plus x squared over 9. A couple options. One option is to simplify the complex fraction first, multiply top and bottom by 9, but some of you saw there was a 9. So what could we do? 1 over 9 times 1 plus x squared over 9 ends up getting us 1 over 9 plus x squared. Dun 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 dee. But you could have done times 9 over 9 right here. You could have done times 9 over 9. And if you had, it would have been 9 plus x squared with a 9 on top, and then those 9s would have reduced. You would have gotten the same place. The same place. Have you guys got that one right? Nice. Have you guys have the work that gets you to that right answer? Okay, a few of you guessed. Good. That's good. No, that's a strategy, though, right? That is a strategy. It's valid. But how many of you guys, if you didn't get it right, had the idea? Okay. Had the idea. Number 91. What is the slope of the tangent line? What are we supposed to do? Slope of the tangent line just means, oh. So I just take the derivative and I plug in. Yeah. So then derivative real fast for number 91. How do I take the derivative of what rule is this? Chain rule, and then ln of u. Good. Those are the rules I wanted you to think of. So then, Thomas, you started going for it. What is the derivative of ln of u? Good. 1 over your u, your blah, right? Times? Yeah, don't forget chain rule, u prime. That's the first piece. How do I take the derivative of arctangent of u? 4x is 16x squared times u prime, which is 4. Think about what's in the inside, that's a u. What's in the inside, that's a u. So then, can we make this super pretty? I suppose, but what do we need to do no matter what? Plug in, right? So I'm just going ahead and getting it ready to plug in. What are we plugging in again? Oh, I already did it. Sorry. 1, yeah? And 1 and 1. So I end up with 3 over 2 plus 4 over 16, which is just 1/4. We'll do a quick common denominator in case you want to see my math, what's going on in my head. 6/4 plus 1/4 is... What went wrong? Good. It's not 1 times 16. My brain did a silly thing. It's 4 over 1 plus 16, which is 17. Simplifying is not going to be quite as much fun, huh? Multiply this by 2 and this by 17. And if you guys are like, I'm wrong, I know I'm wrong. Wait, isn't that 34? Ah. So I have 8 34ths plus 51 34ths, which ends up being 59 34ths. Dun, 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 D. Hey, look, add it up. There you go. Not on purpose, but ADD. Oh, I guess that can mean something else. Anyway. How many of you guys got right what you thought you got right? Nice. Anybody get all 3? Ah, yours got it. Good job, kiddo. But she also felt like she got it. Okay, you guys have any questions before we leave? Numbers 89 and 90 and 91. For my OCD ones, I circled one and not the other 2. I'm annoyed also with it, so there you go. Anything before we leave it? All right, let's go check that 2.6b and see how you guys did, see what questions you guys have. Section 2.6b. As you guys open it up, I have your ready. It's coming, hopefully. But we can go ahead and start checking even without it. Section 2.6b. Section 2.6b. All right, number 24. Started off pretty easy. Number 28. Got a little bit harder with that square root, but hopefully made it a 1/2 power. Number 34. Wasn't too bad with that 3x, but the arc cosecant formula takes a little bit of finagling. The 3's were able to reduce because they're just constants, but I could not take away the absolute value from the x. Couple more seconds. 24, 28, 34. Moving on down to 54. He's going to take up a little bit more space, and you need to plug in unit circle backwards. Could you do it? Could you do it? Please, please, please take to heart the following statement, okay? It would be a shame if you knew how to do the calculus, but you couldn't get the right answer because you didn't know the trig. You hear that, right? It would be a shame if you could do the calculus, but you couldn't get the right answer because you can't do the trig. What am I talking about? What do you have to do at some point in this problem? This is the calculus. This is plugging into plugging in root 2 over 4, which is a little messy. So it'd be a shame if the algebra messed you up, but it'd also be a shame if the trig messed you up. Oh, wait a minute. Did you actually have to do any trig? Ah, they were too nice to you. What'd they give you? They gave you what to plug in, and they gave you the angle that came out of it. Ah, little stinkers. But they could have just given you x equals root 2 over 4. And you would have had to find y for your y1. Do you know how to plug in a ratio? I should say, I apologize. Do you know how to plug in a value to an inverse trig and get out the angle where it coincides? This one you would have plugged in. The 4's would have reduced. Arcsecant of root 2. Oh, I don't know that. Oh, secant is 1 over cosine. Okay, so arcsecant of root 2 is when cosine is 1 over root 2. I don't know that. Oh, that's root 2 over 2. Oh, that's pi over 4. Just warning. I know it's hard. I know it's not easy, but some of you need to practice trig. Or come in and just be honest and be like, I don't know my unit circle. And let us practice with you. That was the very last even, though. I gave you mostly odds because I wanted you to be able to check it in the back of the book. So, guys, where'd we get stuck? Evens or odds? I'm ready. AJ. 35? 55. Anything before 55? Patricia. 28? Anything before 28? Okay. Anything before 28, though? Okay. So you guys keep me honest. I'm going to say number 28, and then I think, Rachel, yours is next. And then, Thomas, what was yours? Oh, okay, both of you guys had 31, and then we're going to end with AJ unless someone else has one in between. Sorry, Patricia, back to you. It was number 20. What's going on with him? Okay, he's messy simplifying. His rule's not bad though, right? So, what's the rule for arctangent to you? Studying for a forever quiz next week. Probably not Monday because that's kind of mean. It's a Monday, but probably Tuesday. I'll keep reminding you. Now, some of you are like, I can't do this in my head. Okay, if worse comes to worse, just write down what you need to do. You need to prime that guy, right? If worse comes to worse, if you're in the zone, you're like, I know my formula. 1 over 1 plus u squared times, I don't know. Prime. Okay, put him in, and then off to the side, be like, okay, I need to take the derivative of this guy for my u prime. But do we want to take the derivative of him written like that? No. Taken your u and rewritten him. True? So when you went to go take his derivative, you just bring down the 1/2, make it a negative 1/2, so you can plug into that u prime. 1 over 2 square root of x, negative, pops them down. 1/2 gives them a square root. What happens with the square root squared? No. What was the Okay, moving on. Number 31 was the next one I in between. Okay. Number 31. Why don't you guys like him? How was he to begin with? Like when you first saw him, how bad was he? Well, but what rule? There is a chain rule, but what's the bigger picture? Product rule. You guys see it times, right? I see it times. Come on. Product rule always starts off with second, just rewrite it. If you don't like the arc sign, you could make it what instead? You could make it sine inverse, but just because the problem has arc sign, I'll go ahead and leave it. Second, d first. Okay. How to take the derivative of e to the u? E to the u times u prime. Don't kill anything. E to the u times u prime plus first d second. Ooh, what's the derivative of arc sine? It's just of x. It's a pretty one. Do you have it memorized yet? Prime will just be 1. Now, why am I purposely taking extra time to come over here and to make it a green pen? Oh, that's not right. Lo siento. Where's my plus? There's my plus. Okay. What am I doing? Took all that time because something's in common. It's in common. Yeah, e to the 2x is in common. So I can pull out an e to the 2x. I have an arc sine of x. Oh, with a 2. Poor little guy. Plus. I don't know. I think for me that's as far as I would naturally go until I would go to the back of the book and try to make it match. For those of you guys that did that, is that okay? So it was just a product rule. Some people would have messed up on the product rule. Some people would have messed up on the u. And some people could have messed up the arc sign. And maybe you didn't see that the e to the 2x was shared. You could pull it out, and then what was that? There's not really a nice way of putting those together. If we needed to, we could do a common denominator, but it would just make things worse. I heard something in the 50s. Was there anything earlier before age 35? Ooh. 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 Now, you guys already dealt with homework last night. You already saw it. You already thought about it. You already had CalcChat to go consider. But why am I still coming back here to my desk and picking up this guy? How many chains are there? Really just 2. Really just 2. There are 3, but the third one would just be t, whose derivative is 1. So t is kind of like our x. He's our last guy. There's really just 2. Who's the outer guy? So before I can ever get to who's inside of sine, what do I have to deal with first? Sine. Remember, if you need to, f is equal to sine of u, and u is equal to arc cosine. How do I take derivatives? One piece at a time. What's the first thing I do? Derive. What's the derivative of sine? Cosine. Cosine of who? Cosine of u. And then you have to come over here, which means this is going to be cosine of arc cosine times. That's just the first piece. So my h prime is equal to cosine of u times, we'll come back, cosine of this whole thing, take the derivative of the outside, keep the inside unchanged, and then what am I allowed to deal with? Inside. Okay, so what's u prime? Well, arc cosine, isn't that the negative one? That looks a lot like sine. 1 minus u squared times what? T. That's just 1. That's, I guess you could say there are 3, but his last derivative is just 1. So I can go ahead and plug that in. Is that all in terms of t? Yes. What could they have done, though, to simplify? Yeah, they're inverses of each other. And so if they're inverses of each other, like an e to an ln of an e, a square root of a squared, a cubed of a cubed root, what's going to happen? They're going to reduce to just the argument. People who checked, does that look right? Yeah. Thomas, what was your question, bud? Oh, okay. Okay, now we're going to AJ's unless someone else is going to stop me. We're going to 50, 55. All right. Is that the next page? Smartboard fail. Sorry. 1 second. If you guys got 55, you can get your notes out and get it ready. But the directions for 55 are equation of a tangent line. Double check me, but I think that's what it was. I looked really fast. Equation of a tangent line. Why can't I come down here and say, oh, look, they were so nice. Dun, 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 dun. I'm halfway done. Because what they give me? The point. So what's the only part that I need? And the slope is the same thing as the dy dx such that x equals 1 and y equals 2 pi. So let's come over here and say, oh, I think I need a product rule. I'm going fast because you guys have already gotten to see it. You had CalcChat to check it out. Just got stuck somewhere along the way. Second, just rewriting arc cosine of x minus 1. D first. Ooh, you had to know your unit circle for this guy. Plus, first, d second, 1 over the square root of 1 minus u squared times u prime. It's just 1. Could we make it pretty? I suppose we could FOIL and combine, blah, 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 blah. But we could also just plug in, couldn't we? What are we plugging in? 1, 2, every single x spot, right? So I can say dy dx. There are no y's, so forget that. Just plug in x is 1. Arc cosine of 0. Uh-oh. It'd be a shame if you could do the calculus and you couldn't do the trig. 4 times 1 is just 4. 1 over, well, 1 minus 1 is 0, and 1 minus 0 is 1, and that's all just, okay, fine, 1. We're trying to plug into this guy, so we'll come back to him in just a second. Arc cosine of 0. Remember, with trig, we've talked about it a few times. What goes into an inverse trig? Usually sine of, cosine of, tangent of. You're doing of angles, but what goes in with inverse? Ratios. And we're trying to get out an angle. For what angle is cosine? I'm thinking of the cosine curve. That's where my brain goes. I don't know why, it just does. For what angle would cosine hit 0? Pi over 2. For what angle would cosine equal 0? Pi over 2. Times 4 plus 4 would be 2 pi plus 4. 2 pi plus 4. I don't know if they simplified, but that's the general gist of it. Did they simplify? Anyone who has it? Like get y by itself? Yeah. Double checking real fast. We're plugging in 1, right? Oh, I put my negative in my formula. Thanks, Ryan. That's totally going too fast. Yeah, I didn't put my negative for our cosine's derivative. Sorry, I didn't track for a second. Thanks, Ryan. Pi minus 4. But then if you need to get y by itself, get y by itself. All right, cool kids. We spent a lot of time on this, which is good in some ways because hopefully it helped answer questions and with the APMC. Hopefully it gave you a chance to kind of be like, okay, after the homework, how am I doing on this general topic? While I'm up here in your homework solutions, I want you guys to check out the next homework. Now, that's review day. So there are only 1, 2, 3, 4, 5 evens. Only 5 out of this whole homework. The rest of them are odd. But what do you guys notice about the answers? Multiple parts with seemingly a lot of work going on, right? What's section 2.7? Something that we really need to get into. So here we go. Section 2.7, the final section of chapter 2b. One of the reasons, do I want to go here? We'll come back to that. Basically what I'm telling you is that with the rules that you guys have now learned, you could take the derivative of any elementary function. And we'll get back to this. Basically it's kind of monumental in that we have now covered officially all of the derivative rules for algebraic and transcendental functions. And with all of those rules, you could derive anything given to you, meaning it would be possible to derive with the rules that you know any possible function that is a real function. But we need to go on to finish off chapter 2. So let's go ahead and do the monumentalness maybe more tomorrow. Well, because if it's an imaginary, like we're not dealing with complex numbers in calculus 1, calculus 2. Does that make sense? But you could derive anything. Or a certain derive anything. Integrals, which is the whole going backwards thing, the area under the curve thing. We learned some rules, and then we learned some strategies. Then you learn some more rules in Calc 2. And you learned some more strategies in Calc 2. And then you learn that there are these things called integration tables, just tons and tons and tons and tons and tons of other rules. And if you've ever heard of Dr. T, he used to teach here a few years ago. He had a big old book of integration rules. Impossible to memorize, not practical to memorize. Let's just say integrals are a lot harder. But anyway, before we finish off chapter 2, we only had 3 sections, 2.5, 2.6, 2.7. I split 2.6 into 2 parts. General, inverse functions, and then derivatives of inverse trig, because they were kind of different, even though they were related. This section is one of the reasons why there's only 3 sections on this test. Related rates. But here's the cool thing. Related rates, to be honest, is one of my favorite derivative word problems. I think it's one of the easiest. Doesn't mean your brain doesn't need to get used to it, how to read problems, how to recognize what to do. But I think it's one of the easiest. Bear with me. If you see a related rate problem on the AP, hopefully you're like, whew, all right, here we go. Got this one. But we got to learn how to do it. So, real quick, if you have to take the derivative, right? And actually, in related rates, we're almost always taking the derivative with respect to t now. T usually stands for math. Time. Good. Derivative with respect to t. Chain rule. We're going to have to use it because we're going to be taking the derivatives of things like, I don't know, a A in math almost always stands for what? Area. So if I need to take the derivative of an A, question, does A match up? No, but okay, hold on, it's a to the 1, so isn't that just going to be the derivative is 1? Like the derivative of y is 1, but what else do I need besides the 1? An A prime. And what's your A prime going to be? Patricia already said it, say it louder. Just like dy dx, it's going to be dA dt. That's just chain rule. If I'm taking the derivative of something where the variables don't match up, no big deal. Take the derivative. If it's an a, it's going to be 1 times dA dt. If it's an a squared, it's going to be 2a times dA dt. If it's a square root of a, it's going to be 1 over 2 root a times dA dt. Take the derivative of whatever you have, and if the variables don't match up, what do you have at the end? A u prime, or in this case, a dA dt. But you're also going to have to think about implicit differentiation. So what if we had to take the derivative of something like a equals pi r squared? Ooh, I do that? Now it's messy notation. But if we had a formula like a equals pi r squared, could I take the derivative? Yes or no? Yeah. Implicit differentiation says go for it, so I could take d dt of both sides. Implicit differentiation says go for it. You could take d dt of both sides, and what did we just learn is going to happen on the left side? Right. There's going to be a dr dt, I totally agree, but that's our u prime at the end. How do we derive pi r? Oh, I don't know, product rule? What's pi? A constant. What can I do with any constant? He's chilling. Who am I going to derive? What's the derivative of r squared? Oh, so bring down the 2. The pi is a constant, and then it's going to be r times r prime. Derivative of a is 1 times a prime, dA dt. Derivative of pi r squared, pi is a number, is 2 pi r times r prime. And just a few of you are like, that's interesting. The derivative of area is circumference? Oh. Anyway, it's another topic for maybe another time. But anyway, it's kind of cool. Can anyone think of a natural scenario where a circle is changing size? Derivatives, remember, change, movement, motion. When would a circle be changing size? Maybe, except if you're blowing up a balloon, and Michael, that's actually perfect for this section. If you were blowing up a balloon, the area wouldn't be changing. The volume one would. So we would take another formula. We would take v equals 4/3 pi r cubed and take his derivative. And we could maybe figure out how fast the balloon is expanding or shrinking, right? Because it could be deflating. When could an area be changing size? Huh? Yeah, I was thinking water. Oil spill in the ocean. And if you're thinking like the surface area of the oil and how it's expanding, right? Because if you spill oil in the ocean, it's going to whoosh, whoosh, whoosh. Now, yes, you could do volume also and figure out how quickly like it's trickling down to the wildlife, to the sea life. What do you call that? Marine life, sure. Anyway, sea creatures. But if you're talking about like the surface area of the, surface area, that could be a balloon, surface area changing, but that'd be a different formula. Surface area of a balloon isn't pi r squared. But area of a circle, like the oil spreading, that could be. This section is all about quantities changing, but not just one quantity. If the radius changes, guess. If your balloon, if the radius changes, then the volume changes. And they don't change at the same rate. And here's a simple reason. Radius is measured in, I don't know, something like feet. Area is measured in something like feet squared. Would the rates be the same of how many feet per second being how many feet squared per second? No, it doesn't make sense. So this entire is built off of one scenario, like area of a circle, one scenario, like volume of a balloon. One situation, but one situation with multiple variables and having to figure out how the rates are related, of how fast one quantity is changing with respect to another. Now, I do have a demonstration, but I just realized I don't think that program got downloaded on my computer once they wiped the hard drive this past summer. So let's go ahead and just move on to this example. I'm going to do an example. Let's do the steps. Nope, I'm just going to solve the example. Tomorrow we'll write down the steps. The steps are right next door as to what I'm about to do. But I want you guys just to think through the example with me, okay? Whenever you have a word problem, do you write the whole thing down? No! Just write down the important stuff. So what's the important stuff? Conical tank? I don't know. We have a cone. What's the important stuff? If I were you, I would draw the picture. This is going to be actually one of our actual steps. Draw the picture of a cone. What are the dimensions, or what are the different measurements of a cone? Well, radius is pretty important, right? What's another good measurement for a cone? Height is pretty important, because if we're talking about water in a cone, I'm almost positive we're talking about volume. The same reason for Michael and his balloon, I had to go to volume. I'm talking about a three-dimensional shape and something inside, I'm talking about volume. So I'm going to go ahead and right now, as you guys are drawing your picture, I'm going to write out the volume of a cone is 1/3, back to geometry, pi r squared h. 1/3 pi r squared h. Area of the base, pi r squared, it's circular, times the height, but that would make a cylinder. I need to go 1/3 because it's a cone instead. And here's the idea. You were given a paragraph of information. But oh, how nice it would be. Oh, how nice it would be to be able to take this whole paragraph and just put it into a few mathematical statements, which is what I'm about to do. Height is changing at a rate of height's rate. And the radius is changing at a rate of. Guess what I can do with that information? I can say rate of height. Rates are derivatives, guys. So I can say dH dt is equal to negative 0.2 foot per minute. And I can also say rate of radius dr dt is equal to negative 0.1 feet per minute. When we see rates in a word problem, we think derivatives. They give us the quantity height, and then they say per minute. I know it's per time. They give us the quantity radius, and I know it's per minute. It's with respect to time. Hence the dr over dt and dh over dt. And then they tell us, what is the rate of change? Okay, things are shifting. They're saying they don't know the whole thing. They're shifting. This is the question, this is the find. What is the rate of change in the volume? Pause. When? That's all clues. Oh, seriously, right away, the bell just rang. Okay, I'm just going to show you guys the dv dt such that r equals 1 and h equals 2. Some of you are like, you take a derivative and you plug in stuff and you're done?